Hi everyone, it's Alistair from Redburn Design, and in this video we're going to talk you through how to design. This is an old Intense M1 back from 2002, 2003. So yeah, let's get into it. So this first step is obviously to set up our geometry skeleton. So I found some numbers online from an old forum thread, and then I downloaded a couple of photographs. That's really all we've got to go off at the minute. We haven't really got any proper data or kinematics points or anything like that. So we're going off an image, a photograph, and some kind of converted geometry numbers. So right now I'm just setting up this assembly file. So again, if you haven't watched, I tend to model big assemblies like this in context. So I have a video about in context modeling, which I'll put in the description. But this is all being modeled essentially or based out of an assembly file. So you can see here on the screen, I'm sort of inserting what I've got so far, which is my geometry skeleton, the photograph that we're going to base from, and this kind of becomes like the main master assembly that we'll design all the parts from that point. Okay, so you can see here we've got our suspension layout, we've got our geometry layout, and we're just going to hit design in context. So we're in a brand new part studio now, and essentially we'll start with the front triangle. So I'm picking up the kind of seat tube center line, head tube center line, and then I'm just going to kind of, again, we're going to use a mixture of the image and then obviously some fixed points that we'll know. We know a seat tube diameter, we know kind of head tube diameter, so we'll use those as critical dimensions, and then just generally try and lay it all out on top of the photograph to try and, I guess, scale it and get it as accurately as we can, or as accurate as we can. So, and then we'll come back and tidy up a lot of dimensions afterwards at a later date if anything doesn't work or if there's no clearance on certain elements. So here, yeah, you can see the kind of seat tube layout. We're going to work on the head tube layout now as well. Again, back then it was probably a 44mm kind of press-in cup headset back in 2002, 2003. So we're just putting some basic dimensions in here. Again, just a straight tube. We can always come back and put some butting in there or some bearing tolerances and things at a later date. But for this, this is kind of satisfactory. And again, BB shell, put the kind of simple round tube stuff in first and then work from there. So here we're going to start working on kind of main pivot. So the bottom bracket and main pivot are kind of like an extruded or CNC cluster. And again, we've got some kind of estimations on bearing sizes. Again, you can kind of go digging as deep as you want to try and find out some more detail on this stuff, but we've made a few estimates, and again, just referencing everything off the picture. But once we've got a framework there, we can go back. And yeah, you saw that picture there. That's kind of something I got off the internet and shows a bit of a breakdown as to what the parts might look like and how the construction is, and then we can make assumptions when it comes around to kind of extruding these parts into 3D from there. So yeah, and again, we've already done our kinematics layout, so we're building off that because we're designing in context. All of that critical locations for those points exist in the assembly file. So again, we can just design in this layout off that. And here we're starting to, I guess, put an outside construction of the front triangle together. Again, the way I'm laying this out in this scenario is just to have a front triangle kind of sketch that I'll create a subassembly. So I'm going to create a front triangle subassembly after all of this, and then that's when I'll start doing my modeling. The reason for that is just because we're going to, the full frame is going to be made up of a front triangle, a rear, and seat stays and chain stays and a rocker link, and the front triangle comprises obviously of like a couple of different tubes, so it's a subassembly in its own right. So we've got to start somewhere though, so we're starting in this main general assembly file. So yeah, you can kind of see I'm flicking back and forward from this image to try and help, I guess, understand how it's all been constructed and where some of these lines should be going. Yeah, it's not totally accurate, but it's kind of the best we've got. So yeah, we're just trying to get everything constrained and lined up as best we can. And obviously, as you go through it, there will be some sort of symmetry and some lines will make sense when you look at the image in the background. So it's just trying to match those up as best we can. And then I'll fast forward through the bits that don't really require any commentary. So we finished front triangle. What I'm doing now is essentially taking these sketches and importing them into our kind of subassembly file, and then fixing them in location because we don't want them to move. There's not really any point in putting mates in at this stage. We can just fix those because they're not gonna move. And now essentially starting on the modeling. So you can see I've renamed this part studio as seat tube. So I'm just gonna probably revolve this, and then we'll add in the little kind of miter at the bottom of the tube, which at the time of modeling this I didn't really know exactly why that was there, but when the model's finished and you compress the suspension, obviously that actually leaves space for the rear kind of rocker link and seat stay, to clear the whole frame. So yeah, we're just kind of adding this seat tube in. I think modeling this as a surface, and then we'll thicken that to the right thickness. So it's probably a 30.9 seat post, from what I would imagine a downhill bike was back in those days. So yeah, we're just going to give it a wall thickness, check the internal measurements, make sure that's all right. And there's a seat tube, so we'll name the part, and then we'll essentially start to bring that part into our sub-assembly. Okay, so I've gone ahead and fast forwarded through this, but I'm just modeling the head tube to kind of go with the rest of the front triangle, and then making a start on this bottom bracket main pivot cluster. So again, referencing the photograph that I have, it's a pretty simple part, which makes life a lot easier. And generally, I'll try and extrude it in halves and then mirror if I can. In this case, there's not really much point in doing that. And again, all this stuff just gives us a basis. We can come back and modify it later on, because we don't really know how wide our main pivot needs to be, so we're making some assumptions of clearances. You know, we know the BB shell is going to be 68 or 73 itself, and then there's going to be some bearings pressed into that main pivot as well, so we're just going to modify that probably after we've got everything kind of laid out. So I think it's good practice too to just kind of get something on paper, you know, and get a bit of a 3D model in place, and then you can always come back and refine, which is why in context modeling is so good, because you can modify one part once you've got a bit more information on it, and then everything else that's kind of relevant to that will update automatically. So it's super good way of modeling, and super useful. Okay, so now we've got kind of top head tube, seat tube, and bottom bracket cluster. We're going to start working on the down tube. So again, in context, we're going to just put a bit of a layout sketch on this. So again, we can draw this back from our initial side profile that we drew for the whole front triangle. So it's a good way to reference it. And then we're just going to create essentially a framework with which to design our tube. Luckily, the construction of this Intense M1, this kind of down tube was just a physical tube, and then there was some formed sheet aluminium that was kind of welded on above it, which we'll get to next. So this we can simply extrude this. I don't think there was any taper or any weird profile, so we don't have to get into too much detail on the down tube, luckily. So again, I'm just putting a bit of a framework at one end. If it was a tapered thing, maybe you'd loft from one end to the other, but in this scenario, it's just kind of a rectangular tube with top and bottom kind of curved surfaces. So we're just going to build that out and then extrude that, and then get that added as well to our front triangle sub-assembly, and then that leaves us kind of the main body of the work to start after that. Okay, so this kind of final piece of the front triangle, which is this kind of formed aluminium sheet metal part, I'm just looking at a couple of images. This is all we've got as a reference for now, really. So this is an article from Pink Bike about the kind of the history of the M series from Intense, which was really helpful for getting information from. Again, we've already got our front triangle sketch created at the start, so we're going to use that in a new part studio and just essentially try and I think the design approach I took for this part was to extrude it all out as a solid, and knowing that I could then shell it later on. So that's kind of what we're doing now, trying to get a closed side profile that's fully constrained, and then we'll extrude that out and, like I say, shell that after that. And then those kind of pressed contoured reliefs in the or pockets in the frame, which add a bit of stiffness and strength, we'll kind of add those in right at the end, and then shell the whole thing after all that's been finished. So that's kind of what we're doing now. Okay, so we've got our kind of external sketch done now, so we're just going to extrude this out, like I said, base it off the thickness of the main pivot, essentially, because we know that that's kind of the widest point that it's got to meet. So we can use that face that we've got and then offset it back by a couple of mil to leave space for the weld as well. And then, yeah, like I say, it's got to match the head tube. And the seat tubes are always a little bit narrower, so we'll add a surface cut later on to try and give it a bit of profile, and we'll do that across the whole face, just so that there's no seams or edges across. So yeah, we'll cover that in a little bit. But we've extruded out. We've got our solid, and we're just going to again keep good housekeeping and try and rename these parts as we go. And we're only going to do one side because it's symmetrical and we'll mirror it across. So now we've inserted it and fixed it into our subassembly. So again, you can start to see, and because it's a subassembly, we can check references and off the other parts and make sure that everything is dimensioned relative to each other correctly. So that's kind of what we're doing now. So this part, essentially, we're gonna add that kind of side surface across. So that's going to help us get the pressed formed aluminium sheet better, fitting better at the seat tube, which is narrower obviously than the bottom bracket and the head tube. So just starting a sketch on the kind of the end of that formed part, and then we're going to add a spline curve in that's going to just give us a nice transition from the bottom bracket section up to the seat tube. Again, we don't have to be super critical, and that spline could be a bit more of a complex shape if you needed to, but I think for the purposes of this, I think this works quite well and gets everything a lot closer to kind of where it needs to be. So we're just constraining that, and then we're going to extrude the surface the full length, and obviously we want it to completely cover the whole part that's been extruded, and you can see here. So we're just going to tweak that, and then we're going to split the solid with the surface and then remove the outer shell. Doesn't really look any different visually, but you'll see now that it's a lot closer to the seat tube diameter without really affecting the head tube and bottom bracket section. So we'll get a much nicer interface for where welds would go if this was being turned into a production part. Okay, the next thing is these kind of pockets that are going to add some rigidity and strength. So I'm just going to offset the outside edges and start creating these little pockets. Again, we've no drawing to go off, but you can kind of look at the reference images, and I'll flick back and forward to that, and you can make some assumptions that it's an offset from the outer edge. So yeah, we're just going to offset these, try and add some radius edges that look roughly proportional, and then kind of there's 2 or 3 pockets throughout this whole section, and again they'll add some strength and rigidity to this, as well as giving it, I guess, the kind of unique aesthetics that it was pretty famous for. And this technology was kind of used quite a lot by a lot of the American brands. I know Foes did a lot of the same kind of style of sheet metal forming. So yeah, I don't know why it's not used as much now. I guess hydroforming and a lot more carbon bikes probably take away some of the need for it, but yeah, I think it had a very unique look, and kind of it gave bikes a lot of volume, I suppose, which is maybe why they're not used now as much. But I don't know, I thought it looked pretty cool. So I actually redid these pockets. So the first time I just kind of extruded these and removed material from the solid. But what that did was give me a kind of a weird edge when I wanted to add that chamfered kind of 45 degrees around it. So I sacked that off, went back, and I'm just going to essentially split the face and offset those faces, and then apply that chamfer with a loft. It wouldn't be an issue with a planar kind of flat surface, but because we added that surface cut to this piece to kind of blend into the seat tube, we've got a bit of a weird curve there. So turned out that this was a much better way of achieving the same result. So you can see me offsetting the surface, shrinking it down, and then essentially I'm just going to loft kind of a chamfered edge from each of these little insert faces. So I'm going to select the whole chain the entire way around that part, and then match that up with the external surface, and you'll see here it kind of adds a seamless kind of chamfer the whole way around with no edges. So yeah, that worked out kind of a lot better to do it that way. Just repeat the process for the other 3 or 4 pockets that are there. Now we're just adding some nice radius edges along those pockets. We're going to add some chamfers along the outside and then shell this whole part out. And then we've got a right hand or a drive side shelled part that's pretty much ready to bring into the final sub-assembly. And again, we'll mirror that part across because it's the same left and right. So that's it in the sub-assembly. We'll fix it in place. And yeah, all the edges, check all those edges, make sure everything matches up nicely. I mean, there's going to be a bit of a weld bead around that'll cover up some kind of untidy surfaces, but yeah, I think it looks pretty close to the original picture given what we've got to work from. So now we're back in this part and we're going to model in context, just going to miter all of the kind of tube junctions. So the seat tube would just offset a surface at 0 and miter the material away, and do the same for the head tube and the BB, and that'll give us a much nicer kind of interface. We should have no interference clashes then with the final part. Same for the down tube, offset those surfaces, kind of stitch them all together with a boolean, and then yeah, we can just remove that material away from the formed sheet metal part. Okay, so we just finished all the miters on the front triangle. The down tube was the last one to get trimmed, and then essentially once all those miters are complete, we've got a finished front triangle sub-assembly. So from here we just move on to the next part, which would be the rocker link, and then the seat stays and chain stays. Okay, so I've already gone ahead and modeled the rocker link itself as a sub-assembly, so it's got bearings and hardware and stuff in there, and now we're just going to start working on the seat stays. So again, using the reference image and a side profile, we can see that it's fairly straightforward parts. Again, the more complex part will be the top view down, where there's tire clearance and kind of rear hub spacing to factor in. So yeah, we're just again same process, doing a bit of a layout sketch in a part studio that will be used in the sub-assembly itself, and then we'll model everything from that sub-assembly. So we've kind of got 3 or 4 different assemblies in this working document, and everything's referenced together. So this is the part where we bring that sketch that we've just created into the main assembly and fix it, or well, actually we're going to mate it in place with these kind of center mates so that the whole thing will, it's a good way of, I guess, checking that clearances and everything works and functions with the sketch before you start modeling, so you can have an active yeah, so there you see that actually one of the mates must have been incorrect, so that sketch that we just inserted should have kind of moved with the rest of the suspension. It's the equivalent of using blocks in SolidWorks. Onshape doesn't have that, doesn't call it that, but it's the same thing. We're creating a sketch, bringing that sketch in, and it almost acts as its own kind of three-dimensional solid part. So yeah, we're just checking that everything's working there. There was a glitch with the rocker link that I later found out what had gone wrong, so I'll redo it at some stage, but it was just to do with the sketches and the way the sketches were attached. So in context modeling is not idiot proof either. Like it is possible to get modeled up and confused with it. So that's why these sort of multiple sketches are kind of, you've got to stay on top of them and pay attention as you go. So yeah, that's it fixed anyway, and we can kind of crack on with modeling our seat stay assembly. So with the likes of a seat stay model, it's kind of more important to start on that top view. So that's generally where I'll start, and then we can reference some kind of critical sketches off the rest of the frame that's in context. So again, the main pivot, we know roughly where it's going to be and where that's going to attach to the rocker. So we'll leave spaces there, or we've already got the washers modeled in, so we can just reference those faces and kind of start the sketch straight off that, which is good. It means if we ever update the rocker at a later date, that this seat stay will essentially update itself without us really having to do anything. So it just keeps everything tied in and stops you having to remember that if you've updated something and made it 1 or 2 millimeters wider or narrower, that you've got to go back and update every single other part that's linked or related to that. Okay, so we're essentially working on this chain stay yoke, or the seat stay yoke, and we've kind of got that critical dimensions put down there. So we're just going to extrude this into a solid, and then just again check that clearance is okay, check that it looks roughly proportionally correct, and then we'll come back and refine from there. So let's extrude this again symmetrically on that center plane. It's all tied in with that sketch, so we're going to go to the same height as that, and we're going to do the right hand side. So again, on this bike it looks like everything's fairly symmetrical, so we'll just mirror this at the very end once we've got everything kind of working correctly. Again, so we've stuck that seat stay clevis into the seat stay subassembly, and now we're going to start working on the kind of dropouts, which I thought originally were just like a plate, like a 5mm, 6mm thick plate, but it turns out they are they must have been a forged part, so they had a bit of contour to them and some pocketing on the inside, which I later figured out. So you can kind of ignore this bit at the start. I ended up going back and beefing it up because it's got to have a bearing pressed in at that lower horse link position, so that needed a little bit more wall thickness, and then where it joined at the seat stays, it didn't need to be quite as thick. So again, similar to how we did the front triangle kind of formed metal part, or formed sheet metal part, we ended up putting again a surface cut in there that kind of allowed us to leave the thickness where we needed at the bottom. So again, we've put those parts in. We're starting to work on the seat stay tube itself. So again, bit of a center line, making an assumption on the thickness, and then for the purposes of, I guess, speed, we're just going to make these or constrain these tubes to the outside edges of the parts we've already got. And then at this point, I can actually, if I had the bike in front of me, it would have made life a little bit easier, but because we only had photographs to go off, I couldn't work out whether there was a bend or not in the seat stay tube. I think it is a straight tube, but at this point in time, I kind of thought it might have had a bend in it to help it kind of marry in nicely to that dropout. So I added a small bend. I might go back at a later date and kind of remove that bend to the tube and see if I can just get it to mate up nicely with that plate. Again, with the thicker plate that I realized when I realized it was a forged part, that in turn might allow me to kind of tidy up this junction with a straight tube without having to put that bend in it, which I think is probably more realistic. If anyone's got an Intense M1 and can check for me, that would be cool. Let me know if it is in fact a straight tube or whether there's a bend in it. But yeah, I suspect it's fairly straight. Okay, so we've got our seat stay tube in place. We've done some little cuts on the outside, and we're bringing it into this sub-assembly, fixing it in place, and then we'll go through and miter these interfaces between the yoke and the dropouts, and just trim everything back to size, and then mirror that across to give us a right and a left tube. Okay, so at this stage I went back and just gave the photographs a little bit of a closer inspection. Again, I've got 2 or 3 different photographs, and I can see this dropout that looked like it was going to be a little bit more of a forged part. When I'm starting to think about assembling it, then I could see the bearings pressed in, and I realized, well, then we know if it's a 7mm thick bearing, it's definitely not going to fit into a 5mm plate. So it made me think, yeah, let's look a bit closer, and you can see the kind of pocketing in here, which made me realize, okay, that's a forged part, so we're going to have to go back in and make some revisions to the dropouts. So I'm just tidying up, renaming those parts, and gone back in here to increase that thickness up to 10mm, and then we'll essentially from that point, we know that's enough meat for our bearing, our 7mm bearing plus a bit of wall in there as well, and then we'll create this surface sketch to try and give us a more of a tapered profile as it reaches the top of the part. So that's what I'm kind of doing here, starting on trying to create a sketch plane off the bottom. And that can be the tricky part sometimes, like where do you start your sketch on a part that's quite organic and has a lot of curves and things in it. So sometimes you just got to get a bit creative in how you create your planes. But again, this is us sort of creating this surface sketch. So you'll see now we're kind of got to dimension it. And again, it's all based off, there's no frame to measure, so I'm just kind of eyeballing it essentially, but it should hopefully speed things up a little bit by doing that. Okay, now I'm just putting the kind of recess for the bearing into this part. Now we've kind of modified the thicknesses of it all, so we're going to make a 7 or 8mm bore for this bearing to go into, and then cut a relief at the back as well. And then that should get this part pretty much finished, and then we can update that sub-assembly and make sure everything looks correct. And again, we'll stick some little rods on here to try and soften the whole part. And yeah, it looks pretty good. We obviously ignore there's no mech hanger, there's no brake mounts on this, but yeah, you could spend a little bit more time and model those in if you wanted to be super accurate. But for the purposes of this, I'll skip that and we'll go straight to the pockets on the back of this part. So again, much like we've done with the pocketing in the front triangle and other areas, it's just a bit of an offset from there and then kind of offset to the outside surface, leaving a couple of mil wall thickness. Okay, once we got all that done, we'll mirror these parts. So we've got a left and a right, or a drive side and non-drive side. Bring those in and finish off this seat stay sub-assembly. So we'll bring those parts in again, fix them, and bring the left-hand seat stay tube in, and we can change the colors, make them all kind of red to match the front triangle once we're happy with all that. And then, oh yeah, we're going to bring bearings in. I forgot, we've got to kind of put the hardware in. There's no right and wrong way on this. I suppose I tend to build my sub-assemblies with bearings and hardware in those, just to make the kind of final assembly less complicated. But I don't know if there's a best practice or not. This is kind of the way I do it, but I'm sure everybody would have their own kind of preferred way or best kind of method for that. But yeah, so there's our seat stay sub-assembly, and we can now kind of bring that in as we can hide that sketch and bring the seat stay sub-assembly in. You'll see it's carried some sketches with it, so just make sure they're turned off, not deleted, but turned off or hidden. It's kind of a good way to do it from here. And then we can just mate that in place, and again double check that all the mates are working correctly. Okay, finally, we're going to model the chin stay. It's the last piece of the puzzle. And again, the process is really, really similar to what we did for the seat stay. So again, we'll start with a side sketch just to kind of put the parameters in place for that, and then we'll flick to the kind of a top view of that chin stay to try and again factor in with the tire clearance and how the interface, how it meets the seat stay, because like we said, we've already put bearings and hardware in that seat stay, so we should be able to just constrain everything to that sketch. So you'll see here I'm trying to. The chin stay actually, when you reference the photographs, had a little bit of an asymmetric look from the side profile. I don't really know what the reasoning was for that, but it's kind of how it was done. So I end up having to offset the center line a little bit and figure that all out here. But yeah, you can see it sort of comes together reasonably quickly, and it's a fairly simple part. Again, with a single chin stay yoke that bridges left and right, and then a left and right chin stay tube and clevises. Okay, once we've got kind of our clearances and whatnot figured out for the chin stay, we've got one kind of top-down sketch for the whole assembly or whole sub-assembly, and then we'll model from there. So we'll take that chin stay yoke and just extrude that out as a start, and then we'll kind of build off that for everything else. Because we've extruded that kind of top-down profile for this, instead of adding the rads manually in there, what we can do is kind of keep using that side sketch that we had, and use a kind of cool feature that Onshape has called intersect, where you can use kind of a sketch to kind of cut through instead of physically extruding another part. It'll kind of modify the part that we've got. So it's a super useful tool. In some uses, it works really well. So yeah, we'll stick that into a new chainstay subassembly, and then we'll continue to build off of that for the tube and the kind of rear clevis parts. So again, just making sure that sketch is in there, and making sure that it's mated correctly to the right mate points, and then we can start bringing our kind of chainstay subassembly together with the rest of the parts. So here I'm just kind of extruding the tube out itself, kind of putting some miters in there, because I can at this stage. We've got the sketch, and then these dropouts, which are a bit tricky. I had to go back and forward a little bit, because again, getting details off the photographs that I had were kind of hard. But you could see that there was some sort of angled contact or interface there for the weld. So got there eventually, and then yeah, essentially pocketed the back of this dropout clevis part. I'm not sure what it's called. And then yeah, we're going to start mitering everything to suit. So the tube's got a bit of a miter. Again, probably not super accurate, but based off the photo we had, it was not terrible. And now going back and adding some of the kind of details in the hollow pockets on the clevis just to try and match up. And we've got a kind of finished chainstay assembly. So we're going to bring that into the main general assembly again, like we've done with everything else. Just check that those mates go in place. You'll see me flick between static and compressed in terms of the configuration for the full frame. I tend to mate stuff in the compressed setup just so that you don't end up mating to something that's maybe not correct. So it's kind of good, I guess, good practice possibly to make sure you reduce those errors. Yeah, and that's pretty much it. Pretty much a finished frame. We're just going to add some hardware in here, so little kind of screws and fasteners, if I could ever get this one to turn around the right way. Yeah, and then essentially we've got a finished frame. So yeah, I hope you enjoyed that. If you've got questions, by all means stick them in the kind of comment section below, and yeah, hopefully we've got, I mean, I've already had some people kind of suggesting other bikes that we could do a deep dive into, and model in future episodes. So if you've got suggestions, let me know. And yeah, thanks for sticking it out for 32 minutes. It was a marathon, this one. I'll catch you on the next one.